Hey everybody, welcome to Jai with Judah, the video series where we talk about the Jai programming language. So this episode we'll be talking about insert and run, which are two directives that are very different but are used together pretty frequently. So to get started, I know this video is called insert and run, but we're going to be talking about run first, because to understand what insert does, it kind of helps to know what run does first. So run is a directive, like we see here, that has a couple different forms. So this is the first form, and probably the main form you'll see around, which is just the directive and then a block of code, right? Run can return a value at compile time, or a value calculated at compile time. But when you see it in this form, it is really just used for execution, because the return type of this value would be void, right? We don't return anything, so of course it's void. And you normally see this in situations like this, or I use it a lot like this, where we just want to do something at compile time, but we don't care about the result of that, right? The program itself doesn't care about the result. And this is a good example of that, where we're creating a run block, importing the compiler, telling the compiler, hey, this current file, we don't want to generate an output executable, and then we're calling the main function at compile time, right? And so what this gives us is, if I go to main, and I type in some code, and then I run the program on the compiler, it will just run hello world, right? It'll just run our program almost like it's a scripting language, right? And there's no output executable in here. There was just the file, right? So this is running my program like a scripting language, but it's compiled, statically type checked, all that stuff, right? Statically typed, excuse me. So that's the first way you'll see this used, and that's the way I use the most. The second way is with a function call. So if I have a function called foo, I do run foo, right? And let's define a function called foo. Let's make it return int, and let's just say it returns 10, right? So this is a function that takes no arguments and returns an integer, and at compile time we're calling it, right? And of course the order of these doesn't matter. Foo could be in another file, whatever. As long as that file is imported, foo, this will work as you expect, right? So we're calling with this run directive foo at compile time. It will calculate the value, right? So it'll run this function, calculate whatever value, and return that from the run directive. So if I wanted to, I could make a variable called a, which will be a constant because this thing is being calculated at compile time. I could make it a runtime value like that, the variable, but I know it's a constant, and you know it's a constant because it's happening at compile time. And so now if we try to print a, notice this would be at runtime if it wasn't for this. I'm doing this just for the sake of the video, but if I comment this out and we generate an executable, I need to quickly import basic for print. If I do this, this will generate an executable, and if I do insert run, we'll get 10. Right, which was calculated at compile time and is being printed at runtime. So let's go back to not generating an executable. I would prefer not to do that. Yeah, let's just delete everything real quick. There we go. And that worked as expected. So now if I do insert and run again, we get the same result. It's just the lines are a bit blurred for what's at compile time, what's at runtime. Technically, all of this is at compile time, but for the example, it doesn't really matter. All right, so now that we know how to return values from a run directive, there's still two more forms we need to talk about that'll give you the full picture of what run can do. So another one is this, like so. And this is just creating a lambda and calling the lambda at compile time, right? So these two things are technically the same, right? So if I do this, these two things are the same because foo, which just returns 10, and this lambda, which just returns 10, are the same thing. Both of these can take parameters, so I can do, a is an int, b is an int, and need to give it like 10, 20. Same thing with this. And then I need to pass them up here, right? These things are the exact same. It's just we're creating a named function at compile time, or just, in general, whereas this one is creating a lambda. Now, in the case where you don't have any parameters, but you still want that return value, for instance, like this function, we can use the shorthand, which is this, right? And this is the exact same as up here, like so. And all this is just the exact same thing. It's just creating a lambda with no arguments that returns this, this type, or a value of this type. So these are the same, almost exactly the same. We're just doing it with the shorthand. So those are the main forms of run directives that you see, right? So you have the basic block run directives that return void, right? That return nothing. You have the function call run directives, which whatever the return type of this function is, that is what the run directive will return. You have the lambda, or the long form lambda run directives, and then you have the short form lambda run directives. Now there is one, I want to say property that you can attach, or annotation that you can attach to a run directive, and that is called stallable. And what stallable does is essentially, when you have a bunch of run directives in your program that are all doing a bunch of things, sometimes they might have, relationships based on the other one. So one could depend on one that depends on another. And if you run into that scenario where one run directive has to wait for another run directive to complete, you'll get a compiler that says that the run directive stalled out, right? And that is what the default run directive does, right? It creates a run directive that cannot stall, or it is an error if it stalls out. If we do a comma stallable, that will essentially tell the compiler, hey, this run directive depends on something else. It depends on some other run directive to complete. So allow it to stall and spin until that run directive is complete, and then rerun the run directive with the new state of the world, or the new state of the program. And so it's kind of finicky, and it's not even documented that you can do this. It's really, up in the air of whether this will be a thing that sticks around or even necessary in the future. So that's just a quick thing to notice about, or to note about runs, is that if they have dependencies, use stallable a lot of the time, if that is okay, if they don't need to manage their state a bunch. So that is run directives. Now we're moving on to insert, the insert directive. So the insert directive is very, very simple. It could either insert a string of code, like so, or a code block, like so. So we'll do A is 10, right? We'll do like this. B is 20, and we'll try to print A and B. Right, so now if we run this, we get 10 and 20. And that is really all an insert directive can do. So it can insert a string, or it can insert a block of code. Now, that's pretty useless on its own. A lot of the time, if you're doing something like this, why not just type, A10? Or if you're doing this code block, why not just do B20 like that, right? It's kind of useless a lot of the time. But that's where the run directive comes in. Now, there is one thing with the insert, before we go into runs, there is one thing with insert that is used all over the place, and that is within for loops, right? So let's say we have a custom data type, for loops and macros. So let's actually do the macro example. It's a bit simpler. So if I have a macro called foo, and you can mark something as a macro by doing #expand. And let's say we want that macro to take, let's just do a block of code like this. And so we'll do, something before the block of code and something after the block of code. Actually, yeah, let's do it like this. We'll do item is this, and I can't type a grave key on this keyboard, so we're just going to ignore that for now. But let's say we do this. So new int, and we'll defer free item, right? So we have that. And now we can do #insert block, right? And so now we could do something like this, where I have, say, food of a code block, like so. And I could say, oh, we have, item exposed to us. Let's make that 10. And I know that that's going to get freed at the end of this code block, right? Or at the end of this macro, right? And so you could use this with, resource cleaning up resources, or this is commonly done with for loops, actually. For loops are just a macro called for expansion that take a bunch of different arguments, like so, like this, and then you go insert body, right? So you'll do like your for loop of like this, and then you'll insert it into the body of the for loop, right? And that is all for loops are in this language is they're just a special case macro that does insert the body, right? So that's a quick note about where else insert is used. So we know insert can do strings and code, and that's it. But we can also make it do a lot more, right? We can make it through the run directive. We can make the insert directive do a ton, and it's pretty powerful. Let's give an example where, I don't know, let's parse a simple config file, and let's turn the values in that config file into globals, right? So let's go to here, and we're gonna like insert run.conf, .config, I like config. And then we're just gonna make this key value pairs kind of like JSON. So we'll do apple is 10, banana is 20, and strawberry is 30, right? We'll align these nicely, right? And so we want to turn these into global variables, and maybe we'll do some fun stuff where we do like conf apple, conf banana, conf strawberry when we parse them, right? So we're going to use a regular run directive that can return a string. Now remember what I said earlier, where there's a shorthand because we want to insert this code. So we can actually just do this, right? And we need a few more imports. We need file to open the file, and we need string to do some string manipulation on what we're going to do. So let's take our config, and we're going to read entire file. Whoops, I cannot type right now. Jeez. Okay, so config is read entire file, insert run.config. And we're just going to assert OK. Unable to open config, right? So now we have our config. We're going to split it by lines. So split config by new line. And I'm just going to do this sort of quick and dirty. There's a lot of ways you could clean this up, or there's a lot of ways you can make this safer and more platform independent. For instance, you know, that. But we're just going to do this quick and dirty. So we're going to do for line in lines if line.count, and that will just loop over all our lines if it's not empty, right? So if there is some text on the line. And now we're going to do parts is split line by that colon, and we're just going to assert that parts.count is more than one. Say invalid line if it is not, right? So now we'll have our name, which is parts 0, and we'll have our value, which is parts 1, and we're going to trim these just to make sure there's no trailing space. All right, so now we've opened up our config file, insert run.config. We've split it into two parts, and we've trimmed all the white space off. So we're going to quickly need a string builder. So string builder. And we're going to return that because remember we are trying to return a string to be inserted. We're going to do builder to string. And there we go. So now we have our name and our value. So we're going to do print to builder. And that takes a pointer to a builder and a formatted string. So we're going to say, you know, we'll do CFG underscore name is a constant value that. And remember, this is code we're going to be inserting. So we want to make sure that we add our semicolon and our new line. And I'll show you why we add new lines in a second. And then we're just going to pass in name and value. So now if we run our program, you'll see nothing happens, right? So nothing at all happens. But if I go try to print one of our config values that I know exists, so it's CFG apple, you'll see we now get 10, right? And there is no, I'm not pulling a fast one, there's no thing called CFG apple in any file or, you know, module that we're importing. They exist in this source at compile time, and I'll show you where. So when you compile your program, if it creates strings that are inserted, you'll get a .build directory, where you built your project or where you built your file with a bunch of information about the thing you were building. So in this case, we get added strings W2. So added strings is what is essentially a file that contains any strings that are inserted into your source and then the workspace name, which doesn't matter for now. So if we go here, you can see that we have workspace target program. It has insert text generated from in the position that the generation occurred at, which is line 5 right here in our insert run program. And now we see CFG apple, CFG banana, CFG strawberry, right? And we've generated code from some random config file at compile time to be inserted into our program, right? And we can do even more. So let's say, for instance, that we want to ensure that all these values are integers. We can just go here, put int, and now if we run this, that'll still work. But if I go change strawberry to 30.3, you'll see we now get a compile time error that says, here's the site that caused the polymorph, CFG strawberry, int 30.3, right? Number mismatch, type wanted, int, type given float 32. So now we could even do some type checking. We could have Jai do type checking for us based on a config that we've parsed, right? And so if we want this to be a string, or we want, you know, certain values to be certain types, we could force Jai to do that for us, right? And so we're actually just going to remove that. We'll have them be, you know, whatever type they pass in. But yeah, if we go into our added strings, you'll see that that is still working, and we can access these variables, these global variables that we created in our actual program, right? So let's make this a little more interesting, and let's generate, I don't know, what the current environment would be. So this might be a little more practical for some people. So let's create the environment, and we're just going to say production, right? And so you could imagine that we'd have, you know, a staging environment or like a developer environment and all that stuff that we might want to control from a config file, so that where our program could say load, you know, production data, staging data, developer data, like mock data, whatever. And we might just want to control that from a config rather than going and creating a build system or like using a build tool that has all this stuff, and then we have to, you know, do some workarounds where we only load production files in production, right? We just want a simple, you know, way to say, you know, if environment is, you know, production, load production data, right? We just want something like that. And then maybe, hey, if the environment is, I don't know, developer, you know, load developer data. And, you know, let's actually do this. So we're going to go here and we're going to say production and developer. So we know what current environment we're in. And let's capitalize this environment so it matches. And if you notice, we're checking an enum value right here, and in this we're not. So we're going to actually do some manipulation. We're going to manipulate the file in the config to be the proper enum, and we're actually going to change this to just have the config prefix, so that way we don't have that special case right here, right? And so now let's quickly create that enum. So we're going to do, we'll just call it environment is an enum that has developer, staging, and production. And now we're just going to go to this name after we've parsed the name and the value, and we're going to go if name is environment, that's how you spell that. Value is sprint, because we're just gonna tag on this this environment dot prefix when we're creating it. So we're gonna do environment dot that, and that will be the value. And now if we go here and we hit insert, you'll see we can now get production. If we go to our added strings, environment is environment.production, right? And so if we go to, I don't know, staging, nothing will happen because we never printed. And then if we go developer, you'll see we now get the developer prompt, right? So now we're controlling our program using just a config file that we've, you know, whipped up in a few seconds that we can have a lot of power over, right? You could imagine a debug. You could imagine, you know, release build like this, or something along those lines. You could also do, you know, optimization That's how you spell that, right? You could even have some secrets, right? So you could have a secret key that you insert into there. Maybe it's just some string or whatever. You could have, a ton of stuff that is inserted into your program at compile time that, once you run it, you can verify like this and you're good to go. Now, quick thing about insert is it's not just limited to global scoped variables or anything like that. You can insert really anything anywhere as long as the value you're inserting is valid. So for instance, let's create a struct called foo. And let's add some values to our config called foo a, 10, foo b, 20, and foo c, 30. And actually, let's do these as types. That's a bit more fun. Let's make these types. Now this would be pretty bad in reality, but for the example, we're going to be doing it like this, right? So we'll have a foo struct. Let's go to just a regular name, and maybe even a version, some version number. And now we're going to do similar to what we did earlier. We're going to do an insert directive inside the struct that is going to open our config, parse the lines, and return a value, right? Return a string. But this time, we're just going to filter the name. So we're going to go if not starts with name foo underscore continue. And then if it does, we can do name.count minus equals 4, name.data plus equals 4, right? We're just going to trim this prefix off. We know it's a length of 4, and we know that at this point, we're looking only at these that have that foo underscore prefix. And so now we can just do this. We can do foo colon type, and that just works, right? So now if we go to added strings, you'll see we have A, B, and C. It's a different run directive and a different insert directive, so it gets a different position in this added strings file, right? So each insert directive creates a new section in that file, and that is on line 16, which is inside foo. So now we can create a foo like this. So f is foo, and we'll make it an actual variable. Whoops, I don't know what I'm typing. And we know that we're going to have A, B, and C. So I can do A equals 10, B equals 20, C equals 30, and then we're just going to print our foo. But as you can see, foo insert can be used anywhere. So we're using it in this struct body to generate pieces of the struct. So for instance, I don't know, you could have some constant that's like config name, and then you could, generate that to where we could go like foo.config name in our program, right? And it's generated by our config or whatever. It could be generated by anything. You could hit an external API and pull down some data and attach that to the struct for whatever reason. Maybe you, at compile time, you're like, hey, generate the networked version of foo, right? Where maybe you read a spec file that describes how to either serialize or deserialize foo. I mean, in fact, you could even just get the type info of foo, where you could go type info struct. You could loop through all the members, and you could say, hey, if this member is a string, this is how you deserialize and serialize it. Generate a procedure to do that for me, right? At compile time. So where now all we have to do is, modify the foo struct, and it'll generate, some way to serialize and deserialize it. And that is a pretty common use case for insert and for run and insert, and one I've seen quite a bit and one I've used quite a bit. So that is insert and run. That is really all I wanted to cover with it, just to sort of, an introduction on how it can be used, some upsides, some downsides, and some cool things you can do with it. So thank you all for watching. Hopefully you enjoyed this video, and hopefully you learned something about insert and run, and I will see you all in the next one.